Good day. In this video today, I wanted to talk a little bit about winery hygiene with AEB. So why hygiene? First of all, quality. How can you make consistently a good wine if the winery is contaminated? And then the health of the workers. Who wants to work in a contaminated winery anyways? Hygiene is making it look clean by removing the dirt, and then sanitation, so elimination of the invisible fraction of the contamination. A contaminant can be an organic contaminant, and for example, in wineries we see here crystals of tartarates, and then inorganic, rust and scaling. But very important distinction in the contamination is it visible, like a stain, or invisible, microbes. And we clean these two different contamination in different steps. So in the first, we use detergents to lift or the debris or the solids and have them in the rinsing solution washed out. When we have the clean surface, at that point we sanitize. We minimize the load of microbes. When we wash, when we clean, we use different factors. We mentioned a detergent, a chemical action, but then thermal energy, mechanical energy, contact time, they all are in the pool of the cleaning factors. Mechanical factor, we can help providing water jets, tank washing heads, spray for foams. Foam is actually something that goes right into the detergent, and with a mechanical factor helps these detergents to be more efficient. The foam will lift debris and help in this air bubbles facilitate the dispersion of the debris in the water. So a mechanical factor adding in the detergent. When we clean, we also want to look what kind of dirt we're going to clean. So organic dirt, for example, is way more soluble in alkaline pH. That's where we have the saponification of the proteins, where the proteins are the most soluble. They're not soluble at neutral pH, at the pH of water, so it'd be really hard to detach proteins just with water. Same for lipids. Caustic detergents provide the right pH for cleaning these organic compounds. We have soda and we have potash. Potash nowadays, KOH, potassium hydroxide, is considered more environmentally friendly, so it's preferred. It's also more expensive, but it's also more efficient at low temperatures. It has a couple of advantages that justify the extra cost. When we talk about caustic cleaners, we know that they're not gonna do much against mineral contaminants, resulting mostly from the hardness of the water. So lime scales, but also rust, aluminum oxide, they all need an acid wash when is an important problem, or they can be washed away, especially the scale, if we have some sequestrants in the ingredients of our detergents, like AEB detergents have the sequestrants to help with the descaling. But anyways, the water hardness is definitely important when we wash. Water is the vector for all our cleaning products, and it can condition the efficiency of the detergents of these cleaning products. It can decrease the properties of the surfactants, which is a very important ingredient that we will look at. It also can combine with some contaminants like the phenolics, making them harder to detach. So water, and the hardness of water especially, becomes a fifth element, along with the chemical, the temperature, the contact time, and the mechanical action, a fifth element that condition our wash. We define the water hardness as the amount of dissolved calcium and magnesium in the water is expressed in milligram per liter of calcium carbonate, or ppm of calcium carbonate equivalents. So analyzing that, we will have a classification for our water of soft, hard, something in between, or even very hard. When we have an hard water, and especially on caustic condition, we will cause a precipitation of scale. So it's important to have in your cleaner, and all AEB cleaners have scale inhibitors that help the control of the precipitation of the calcium carbonate, leaving a spot-free surface. If you have thermal exchange surfaces and you haven't used these inhibitors, most likely you have an incrustation in the surface, and it's very hard to wash it with caustic cleaner unless you have sequestrants. Another important ingredient that you want to have in your detergent is a surfactant, which is an organic substance that is used to reduce the surface tension of the water. That means making the water, imagine, more fluid. This is because of the way the surfactants act on the surface. You see how they dispose in the surface with their tail on top. The tail is hydrophobic, so it'll go on top, and the hydrophilic pole will go in the water. In this position, they decrease the tension of the water. When they reach a certain concentration, they have another effect. They surround dirt, lifting it and making it soluble in the rinse and wash. Surfactants as a unit to remove dirt. So coming down with their lipophilic tail, anchoring to the dirt, circling all around the dirt, and then removing it with the washing solution. Another effect of the surfactants, we said, is the change of the surface tension. So making the water more relaxed. And in this picture, you see what I mean. So the good wetting, the water going deeper in the pores. So caustic detergents of AEB contain these ingredients. You see the Removil, which is 100% soda flakes with scale inhibitors, sequestrant, and surfactants. See Removil K, 52% potash flakes, 27% sodium hydroxide with scale inhibitors, surfactants, and sequestrants. And then Membrane UF, which is actually a liquid potash solution, which is used mostly for the regeneration of cartridges in the CIPs of the bottling lines. It's also used for cross flows. We have a fourth caustic detergent, which uses the foam as a mechanical action along with the chemical action. So it's a foam that you can spray with a specific application that we can also provide on especially the exteriors of walls and tanks. In this case, this is a picture we took during a trial. And as the foam comes down, physically remove the dirt and can be washed away. We can introduce a second ingredient in this foam KOH foamy detergents, which is called foam KOHB, is an oxidizer, hydrogen peroxide based, that helps the foam to be more active in removing the debris and also eliminates partially microbes. Now, for a chemical to be considered a disinfectant, it has to be registered with the EPA, like for example our Quat2 sanitizer, which is a quaternary salt of ammonium. So the quat salts are actually surfactants that can actually go around a cell, attaching with the lipophilic tail to the phospholipidic membrane, disrupting the characteristic of the membrane, and in this way efficiently killing the microbe. In this case, we see a coronavirus cell being killed by our Quat2 sanitizer, but it can be different microbes, including all kinds of bacteria. We introduce in our Quat sanitizer two different salts, two different quaternary salts of ammonium or surfactants, to have a broader spectrum, because normally the minus of this sanitizer is that it's pretty selective, but by extending to two components, we broaden the spectrum. Other than that, they have all good characteristics. They penetrate very well in the pores, going to kill microbes that are deep in parts where normally the water wouldn't get. They're active in presence of soil. They're non-corrosive, so they can be used manually. They have a residual effect. So when we wash a surface like a floor or a wall, we can actually avoid rinsing, and we will have an extended protection against microbes for the residual effects of this quote sanitizer too. We want to make sure we rinse if we're washing a tank that is going to be in contact with the wine, of course. We also provide the strips that you see in the picture to make sure that you're using the right concentration when using the Quat sanitizer too. That has to be around 200 and 400 milligram per liter. We have another detergent based on surfactants, based on quaternary salts of ammonium, that doesn't require the strip. We make it more simple because it's used in the working spaces, offices, labs, bathroom, breaking rooms. This can be used for washing and sanitizing against the viruses. So very useful nowadays for the safety of the workers. Um, this is called one step because you can use it for cleaning and sanification at the same time. Another disinfectant, very active, that we provide is a mixture of peracetic acid. Um, Peracetic acid is very popular in wineries nowadays, especially in CIPs, because it doesn't foam, because it's easy to rinse, has a very broad spectrum, and a very rapid action. But it has to be used by professionals because it can be very dangerous. Another product that we can use in our cleaning and sanification procedures is hydrogen peroxide, and we have one that we commercialize under the name of Remoxin. Is essentially a bactericidal product. Um, Both gram-negative and gram-positive bacteria are a target, but it needs high temperature, around 60 Celsius, to be very active. Or it can be used as an ingredient in a caustic wash, making it more efficient. In a caustic wash, for example, a combination of Remox and Removil, the two components will give each other an help. So the hydrogen peroxide in Remoxin will help the caustic with the washing, and the caustic environment will help the Remoxin have more heat and more oxygen being released, and so more efficient activity. This combination I introduced because it's very active against biofilm. What's a biofilm? It's basically a viscous film, more or less visible, consisting of a microbiological community firmly anchored to a surface and anchored in a self-generated extracellular polymeric matrix called EPS. So basically you have these microbes going on a surface, anchoring themselves in the biofilm, and being in the sexual stage, and releasing the planktonic stage on top of the film. So you can act on top of the film, but normally the cells continuously exchange the DNA with the sexual stage, making this planktonic phase adapted to several conditions, so very hard to clean and disinfect. And also the biofilm is very firmly anchored to the surface. To scrape it off, we can use the combination Removil K Remoxin. So this explosive combination, hydrogen peroxide and caustic, can actually have an effect in removing the biofilm. Then, like we said, the cells can be very adapted to different conditions, very resistant. So to make sure we have a complete sanification, used Quad 2 sanitizer as a follow-up step. So this is it. Hopefully it was useful. For now, have a good day, and we'll see you in the next video.